Freight, the lifeblood of the country, flowing in a never-ending stream. From tractors to typewriters, coal to codfish, it rolls over the finest railroads in the world. Today's freight trains are longer and heavier, but they keep schedules that were unheard of a few years ago. Running trains looks easy, but there's much behind the scenes that calls for skill, loyalty, and precise training. Perfect teamwork and modern equipment combine to make railroads safe and dependable. The operation of fast freight service makes it impractical to hold loaded cars until a full train can be made up for a single destination. Therefore, trains are dispatched from terminals on definite schedules. Redistribution of the cars is handled at key points in classification yards. New trains are started from these yards and run directly to their destinations. Let's follow a mile-long train as it pulls into one of the country's largest classification yards. The yardmaster has been notified of the arrival time by telephone and has instructed the tower man to route the train to a suitable track in the receiving yard. The train leaves the main line and threads its way into the yard. As the locomotive reaches the far end of the yard, the crew uncouple their caboose. It will soon be assigned to another train. The caboose is the conductor's office on wheels and also serves as a crew dining car and a lookout tower for the brakeman. After the markers or tail lights have been removed and the locomotive has been released for servicing, the train loses its identity and is ready for classification. On arrival, the conductor turns in his reports, which include the number, weight, and description of each car and its load. Experienced men start at once to make up lists for new trains, as the placing of each car is carefully planned. The maximum tonnage for a given train will depend on its scheduled speed, grades it must climb, and weather conditions. Weather reports play an important part in this phase of the plan. An amazingly intricate system of records makes it possible to locate any car in the yard within a few seconds. Telephones and loudspeaker systems not only connect dozens of points in the yard, but through railroad long-distance lines make it possible to have quick connections with scores of other yards and offices. In order to save valuable time, teletype machines are used to transmit switching lists from the office to various parts of the yard. Directions for placing each car are sent to tower operators and yard conductors simultaneously. The hump is an artificial hill which enables gravity to do most of the work of sorting cars. The task of pushing a long, heavy train up the incline is handled by a double or triple unit diesel-electric locomotive, first developed by the New York Central. The yard conductor gives the starting signal to the engineman, and the cars roll slowly up the incline. They are uncoupled as they reach the crest and roll on their way to new locations on the classification tracks. Safety is highly important on the railroad. Safety for employees and safety for valuable freight. The routine of constant checking is never relaxed. At this pit on the hump, a skilled inspector watches the underside of the cars for signs of trouble. Powerful floodlights aid his keen eyes in detecting needed repairs. A small defect may lead to serious trouble if not caught in time. The inspector employs a spray of whitewash to mark a defective car while it's in motion. In a short time, the mixture dries, leaving a plainly visible white mark. After marking the car, the inspector signals the tower man to switch the car to the repair or cripple track, as it is known to railroaders. Lubrication is also handled at this point, where workmen put oil in the journal boxes. The yard conductor is in charge of operations on the hump. Loudspeakers, telephones, and two-way radio give him instant communication with the members of his crew, whether they are in an office or on a locomotive. His copy of the teletyped switch list shows exactly how many cars are to be uncoupled as they reach the crest. Under his direction, a helper unlocks the coupler as the slack loosens the pin, and the car starts to move downhill under its own momentum. A long train is quickly classified at the rate of about 3 cars a minute. Before the introduction of the gravity system, all car movements were made with a switch engine. This was slow and expensive. Today, such methods would be entirely inadequate to keep up with fast freight schedules. Livestock, dressed meat, live poultry, fruits, and other perishable products cannot be delayed. Thousands of cars rolling in at one end of the yard must be kept moving out at the other end. Modern manufacturing methods call for close delivery schedules of raw materials and finished products. Weather conditions sometimes impose a severe strain on men and equipment, but seldom interfere with the steady stream of freight. After the cars leave the top of the hump, they come under the control of the tower operator. He must direct them to the proper track in the classification yard. His list gives the weight and destination of each car. The work calls for a high degree of skill, for the cars come in a constant stream, and several may be under his jurisdiction at one time. In order to make hump operation possible, it is necessary to govern the speed of the cars to prevent their crashing together in the yard. The jaws of the electrically operated car retarder grip the wheels with variable pressure, which is controlled by the operator. By glancing at his switch list to see the weight of the car, an experienced man can quickly estimate what pressure is needed. Before the invention of the retarder, this operation was performed by brakemen, who rode on top of the cars and stopped them with the handbrakes. Although a car passes through several retarders, any one of them could bring it to a full stop. However, the retarder is designed to check the speed of cars instead of stopping them. In order to route the cars to the proper tracks, the tower operators have a group of levers at their fingertips, each one controlling an electrically operated track switch. The operator in the hump tower does the preliminary sorting and sends the cars on to other tower men for further handling. In some yards, a total of 3 operators may handle as many as 40 tracks. Any number of cars may be sent in one group if they're going to the same destination. Careful advanced planning results in a minimum number of movements and a saving of valuable time. The highly skilled operators can judge the speed of the cars, so they will coast to a gentle stop at any predetermined point in the yard. Sometimes a car may have to coast nearly half a mile. Other times, when a track is almost full, it may roll only 200 or 300 feet. On rare occasions, it may be necessary to make a last-minute change from one track to another. In such cases, a switch engine, known as a trimmer, is sent into the yard. This means that all cars coming over the hump must be stopped on the upgrade until the trimmer completes its work. It's very seldom, however, that the smooth flow of rolling cars has to be interrupted for any reason. Keep 'em rolling's long been the railroad man's slogan. The familiar boxcar is the most useful of all rolling stock, for it carries practically everything needing protection from the weather. Hopper cars are used for coal, ore, and other bulk freight. Heavy machinery or boxed freight is best handled on flat cars. Syrup, gasoline, or vinegar all have their own kinds of tank cars. Automobiles ride in specially designed box cars. Another unusual car carries cement in huge containers. Gondolas are all-around carriers for many different loads. Refrigerator cars may use ice in summer or heaters in winter to protect perishable foodstuffs. The list of special cars could go on and on. Different designs, different sizes. A car for everything that can be transported. These valuable loads need protection, and the vigilant railroad police are constantly on the job. They patrol the yards, ride the trains, and check the car seals to guard against theft. There are many kinds of activity in a large freight yard, but the dominating one is the constant movement of cars. An idle car means a loss of time and money for both shipper and railroad. Cars in need of repairs have their own special yard where skilled mechanics work day and night to prevent delays. Wheel changing is one of the most important jobs handled by these crews. When you change a wheel on a railroad car, you must change two wheels and the axle. The ends of the axles are highly polished, for rough spots cause friction and result in hot bearings after a car has been run for a short time. Wheel changing, like all other repair and maintenance work on rolling stock, must be done according to standard practice. Only by this method can cars be serviced by all railroads anywhere in the country. Dangerous spots like these may lead to serious derailments. The constant alertness of inspectors detects flaws before they can cause damage. Precautions, such as measuring carefully for signs of wear, are helpful in forestalling failures. Axles and wheels falling below certain standards must be replaced. Completely equipped car shops are an important part of every freight yard. Without them, it would be impossible to maintain the high-speed service that is a feature of modern railroading. A train is like a chain. One crippled car may be the weak link. A pair of wheels and their axle may weigh more than 2,000 pounds, yet the men who handle them do so with ease, for they know how to use their strength to good advantage. Although a complete truck is a massive unit, it is easily and quickly taken apart for repairs. Under favorable conditions, wheels can be changed in less than 1 hour. Back in the classification section, we find more activity as the various groups of cars are brought together to make up a train. Cars are placed according to their destination and may be drawn from several tracks. Planning the makeup of a fast freight is a task which requires years of experience. Correct placing avoids unnecessary handling at terminals and allows faster delivery. Before a train can leave the yard, it must be carefully looked over by an inspector. He checks all running gear, paying special attention to the journal boxes. Like most other railroad workers, these men are specialists, and the safety of many lives and much valuable freight may depend on their good judgment. Every large yard has an engine terminal where complete servicing facilities for locomotives are available. After each run, these giants must have a thorough checking and servicing. Dozens of men swarm over them, each performing a special task as mechanical, electrical, and air equipment are tested. The ring of the inspector's hammer can indicate hidden trouble to the trained ear. The terrific task performed by these engines makes it necessary to keep them in the best of condition. After servicing, the locomotive starts for the advance yard. The crew has been called for duty and the engine made ready well in advance of the train's departure time. Picking its way slowly through a maze of switches, the engine moves to the head of the train. In the meantime, at the other end of the yard, a crew is busy attaching a caboose. When the taillights or markers have been put in place, the string of cars officially becomes a train, and its movement is subject to orders from the dispatcher. The locomotive assigned to a train may be either steam or diesel electric, depending on the tonnage, speed, and destination of the train. The final yard operations consist of coupling the engine and making a test to be sure that all brakes are working properly. At last, all is ready, and the highball signal sets the train in motion. With a skilled engineman at the throttle, the huge locomotive settles down to the long pull with a mighty roaring of exhaust beats. Few spectacles are more thrilling than the sight of a great steam engine starting a heavy train. Back again on the main line, the fast freights headed north, south, east, or west have been through many yard operations in a few hours. Loaded with hundreds of products for almost every conceivable purpose, the freight train is a vital factor in our everyday life. Whether it be cereal for baby's breakfast or machinery for a great power plant, the railroad moves it 1 mile for an average cost of less than 1 cent per ton. Night and day, good weather or bad, the railroad is on the job, furnishing mass transportation unequaled throughout the world.